First topic is important results related to conjugate of complex numbers. In previous video I have told what is conjugate of complex number. Now these two results related to conjugate. First result is if we have a plus iota b, if we take its conjugate one time we get a minus iota b. If we take its conjugate again, we will get a plus iota b. So conjugate of a complex number is equal to complex number. Second note, conjugate of real number is the same real number. Let us suppose we have z is equal to 2. Then conjugate will also be z bar equal to 2. Because there is no value of iota involved. Next definition, equality of complex numbers. Suppose we have two complex numbers a plus b iota and c plus d iota, where all a, b, c and d from real numbers. These two complex numbers will be equal to each other if and only if their real parts are equal and their complex parts are equal. Look at the statement. For all a, b, c, d belong to set of real numbers, a plus b iota equal to c plus d iota. If and only if a is equal to c, which are real parts, and b is equal to d, which are imaginary parts. Look at example. We have two complex numbers 2x plus y square iota and another complex number 4 plus 9 iota. These complex numbers will be equal if and only if we have 2x equal to 4, which is real part, and y square equal to 9, which is imaginary part. And we get from here x equal to 2 and y equal to plus 3 and minus 3. Next, properties of complex numbers. Reflexive law. Same like real numbers, two complex numbers will be equal. This is called reflexive law if we have same complex numbers. Symmetric law. If we have z1 equal to z2, then z2 will also equal to z1. Third law is transitive law. If we have z1 equal to z2 and z1 equal to z3, then z1 will also equal to z3, where z1, z2 and z3 are complex numbers. Now basic operations on complex numbers. First operation is addition. How will we add two complex numbers? Let us suppose we have two complex numbers z1 and z2. z1 equal a plus iota b and z2 equal c plus iota d, where all a, b, c and d are real numbers. The sum of complex numbers will be denoted as z1 plus z2 and will equal to sum of real numbers plus sum of imaginary numbers. Real part is a and c, so we will add them, and imaginary part is b plus d, so we will add them. So sum of complex numbers is sum of corresponding real and imaginary parts. Consider a question expressed in standard form of a plus iota b. Here we have two complex numbers 2 plus 3 iota and 7 minus 2 iota. We have to add them. So we will add real and imaginary parts respectively. We will add 2 and 7. Then we will add 3 and minus 2. We will get 9 plus iota. Similarly, we will do subtraction with the help of question. Express in standard form a plus iota b. Question is given minus into minus 3 plus 5 iota minus into 4 plus 9 iota. These are complex numbers. First of all, minus will be multiplied in the brackets and we get plus 3 minus 5 iota and minus 4 plus 9 iota. Then we will subtract real parts and imaginary parts respectively. We will get 3 minus 4 plus minus 5 minus 9 into iota, and we will get minus 1 minus 14. So this is the way to subtract two complex numbers. Next, multiplication of complex numbers. Let we have two complex numbers z1 and z2. Their product have two cases. If we want to multiply real number with complex number, look at statement. If k belong to real numbers being a scalar, then k z1 will equal to k into a plus b iota, where z1 is a plus b iota as a complex number. Then this k will be multiplied to a and b iota separately. We will get ka plus kb iota. This is called multiplication of complex number with scalars. Second, if we have to multiply two complex numbers, then what will we do? If we multiply two complex numbers a plus b iota with c plus d iota, we will multiply them as a with c minus b with d plus a with d plus b with c into iota. This is formula for complex multiplications. Consider a question 2 minus square root of minus 4, one complex number, and 3 minus square root of minus 4, another complex number. Square root of minus 4 can be written as square root of 4 multiply square root of minus 1. Square root of minus 1 is iota, so we will get 2 minus 2 iota and 3 minus 2 iota. These two complex numbers. Then we will multiply them by using the formula. We will multiply 2 with 3 minus 2 with minus 2 plus 2 with minus 2 and plus minus 2 with 3 iota. Then we will get 6 minus 4 plus minus 4 minus 6 into iota. We'll get 2 minus 10 iota. Next topic is division of complex numbers. We have two complex numbers a plus b iota and c plus d iota. We have to divide them. We will rationalize them with conjugate of denominator c minus d iota, and then we will get ac plus bd plus bc minus ad by using formula of complex number multiplication, and we will get c square plus d square. So we will separate real numbers and imaginary numbers. We will get ac plus bd over c square plus d square plus bc minus ad over c square plus d square into iota. So we will illustrate with the help of question. Question is that 1 plus iota in numerator, 1 minus iota in denominator, whole square. We will rationalize it. We will get 1 plus iota whole square in numerator and 1 minus iota with 1 plus iota in denominator. We will open the square in numerator and we will get 1 plus 2 iota plus iota square. Similarly, we will multiply 1 minus iota and 1 plus iota. We will get 1 minus iota square. Then we will get 2 iota over 2 whole square, which is iota square. Iota square is again equal to minus 1. Solve the following equation for real numbers x and y. Equation is given 3 minus 2 iota into x plus y iota equal to 2 into x minus 2y iota plus 2 iota minus 1. We will multiply the two complex numbers by using multiplication formula. We will get 2x minus 4y plus 2i minus 1 equal to 3x plus 2y plus 3y minus 2x into iota. We will separate real and imaginary parts. We will get 3x minus 2x equal to minus 2y minus 1, which gave us x plus 2y equal to minus 1, and imaginary part we will get 3y minus 2x equal minus 4y plus 2, named it as equation 2. By simplification, equation 2 yield 7y minus 2x equal to 2, term it as equation 4. Now, by multiplying equation 3 with 2 and adding in equation 4, we will get 11y equal to 0, y equal to 0. Put in equation 3, we will get x equal to minus 1. So x equal to minus 1 and y equal to 0 are real x and y values. Thank you very much.